Okay.
Alrighty, Algebra 1, good morning. How are you? We hope, oh, see, I think we're back in the classroom. I'm like, how are you today?
And good morning, but you might be watching this at 9 o'clock at night. Who knows? Hi.
Well, it's good to see you. We hope that you've missed both of us teaching, because we've missed teaching with each other and we've missed teaching you. So in honor of our last lesson, we figured we would come together and kind of close out our year with one last lesson all together as we can be.
Yes. And so we hope that you've got some paper next to you, maybe something to write with so you can take a few notes as you're going along. Remember, you can hit pause a moment, you can hit rewind. And if you've got questions, you can email us or reach out to us in office hours.
Mm-hmm. Alrighty guys, so we're gonna go ahead and get started. So if you watched Miss Gilroy's video on Tuesday, then some of this stuff right now is gonna be a little bit of a review. If you have not gotten a chance to watch Miss Gilroy's video from Tuesday, you might wanna do that first, because we're gonna reference some stuff from that video. And so the first thing that we want to talk about is just this new thing called quadratics, right? Now, like Ms. Gilroy said, during the school year, we would have a whole unit on this, but we're just going to give you small snapshots of it. And so in a quadratic, we've got a graph, right? And the graph looks like a parabola, and a parabola is like a smile that's going up, or like a frown. Can't do it. There you go, a frown that's opening down, okay? And then some quick facts about quadratics are that the graph is called a parabola. All quadratics have a degree of 2, all of them, okay? And there are 3 structures for the equation. And if you're wondering what those structures are, well, they're in that last box right here. So you've got standard form, and that's written in pink. Okay, so standard form looks like ax squared plus bx plus c. Okay, and standard form gives us some important information. Then we've got vertex form, which is written in purple. And vertex form is written as f of x equals a times the quantity of x minus h squared plus k. And the important information that we get from vertex form is the vertex, right? And I've highlighted those points for you in yellow. And then our third and final structure is factored form. And factored form is f of x equals x minus some number times x minus some number, okay? And those numbers that you're subtracting there at the end are your zeros, aka your roots, aka your x-intercepts.
I was just going to ask you, Ms. Medrano, if those had other names.
Yeah, so they have 3 names. So those are all synonymous: zeros, roots, and x-intercepts.
Okay. Since we know that we're dealing with quadratics or degree 2 functions, and we know that the shape's going to be a parabola, it's good to know some of the parts of the parabola and what we can call them. So on the screen, you should see just a stereotypical parabola that's been drawn in that smile shape that's there, and some points that have been highlighted. So these are key details. So the vertex, that turning point, is there in green. It's where the smile turns around and we get the 2 ends going in the same direction because we've changed direction. The orange thing is our y-intercept, which we know from before. It's where we cross the y-axis. The 2 blue things are where we cross the x-axis. Now, one thing to note is that this parabola has 2 x-intercepts. Ask yourself if all parabolas will always have 2 x-intercepts, because that's something that might be interesting to think about. For that matter, does every parabola have 1 intercept? So it's something to think about and wonder about as we go through this lesson. This lesson in particular is focused on the blue stuff. We know that the factored form gives us those x-intercepts, aka roots, aka zeros, and that's what we're going to be playing with, is can we identify what the x-intercepts are?
Mm-hmm.
And sometimes we're going to get functions that we know are parabolas that are degree 2, but aren't in factored form. And so we can't see what those zeros are right away. What will we do? We know that we've got a parabola. We know that we're expecting x-intercepts most of the time. So what will we do?
So we've got two options when we run into this issue that Ms. Gilroy just brought up. Option one is to factor your equation and use the zero product property. So here's an example. So an example would be when, if I have an equation, y equals x squared plus 7x plus 12. And if I want to factor it, the first thing I want to do is make sure that my equation is set equal to 0. Okay, so I'm going to go ahead and set this equal to 0 because we're looking for those x-intercepts.
Oh. Exactly. I was just going to say, and x-intercepts are where we are on the x-axis, right?
Mm-hmm.
And if we're on the x-axis, then y is 0.
So that's why we're setting it equal to 0. Okay. Once we set it equal to 0, in order to factor it, we are looking for two numbers that satisfy two conditions. We're looking for two numbers that add to this middle term and multiply to that last term. Okay. I always like to write the A and the M, like AM in the morning, just because it keeps it in order in my head. And the A, I just want to point out, the A always goes with the X term. Okay, so sometimes those two things might be reversed. You always want to write it x squared and then the X term and then that last number, the constant. Okay, so numbers that multiply to 12, I wrote myself a list over here. So of all of the numbers that I could think of, 1 and 12, 2 and 6, 3 and 4, I didn't include my negative numbers because I know that they have to multiply to positive 12 and add to a positive number. So I knew that I couldn't have a negative pair. So after I came up with my numbers that multiply to 12, I asked myself, okay, which pair when I add them together will add to 7? 1 and 12 don't add to 7, 2 and 6 don't add to 7. The only pair that works is 3 and 4. So I'm going to go ahead and substitute that in to my factored form. Okay, so now I've got two equations, one written in standard, and once I factored it, it's in factored form. Those two equations give you the same parabola. Okay, it's important to remember that it's the same graph, just wearing a different hat. After that, we use the zero product property. So if you remember, the zero product property is when we set each of those quantities equal to 0 and we solve for x. So we set x plus 3 equal to 0, subtract 3 on both sides, and when we subtract 3 on both sides, one of our solutions is x equals -3. Then you set your other quantity equal to 0. So we set x plus 4 equal to 0, subtract 4 on both sides like we did over here. When we do that, we get x equals -4. Okay. Just remember that when you do this, both of these are your solutions. If you substitute both of these back into the equation, you're going to get 0. Okay, both of these satisfy the equation. And so those are your x-intercepts. There is a second option. Okay. Now, option 2 is we use the quadratic formula. Okay, now the quadratic formula, what does it look like? So we use it if and only if ax squared plus bx plus c equals 0. So that idea of setting your quadratic equal to 0 still has to be true. Okay. Now this is what the parabola, or not what the parabola, this is what the equation looks like. So the equation is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So there are some songs on the internet. Oh, do you know the song, Ms.
We had
Gilroy?
a chance to practice order of operations. Order of
Oh, I thought you knew the song.
Sorry.
Yeah. We'll get an opportunity in a moment to practice some order of operations. And so when do we use the quadratic formula? So we use it when we want to find the x-intercepts. We use it when we can't factor, or when we can't seem to find the correct pair to factor our equation. We use the quadratic formula when our equation is in standard form. So standard form, ax squared plus bx plus c, and we need to identify what those a, b, and c values are. So before we actually start using the quadratic formula, let's start practicing by identifying our a, b, and c. So let's look at number 1, okay? Let's go back to that first equation that we factored. X squared plus 7x plus 12. And the first thing we want to do is the equation set equal to 0. I look at my equation. Yes, the equation is set equal to 0. So I can go ahead and identify a, b, and c, okay? So my a is always going to be attached to your x squared term. Here's your x squared term. Miss Gilroy, there's no number in front of there. Is that 0?
That's just going to say there's nothing there, so A is 0.
Oh, but wait, if A is 0, then 0 times anything will always be 0. So then I don't think anything there would be written. So I don't think it's 0. It can't be 0.
Oh, so then we wouldn't have a quadratic if A were 0, because
Yeah.
that whole term would go to nothing. You
Mm.
know what, Miss Madrano? It's 1. When we multiply by
Oh,
1, we don't change the value.
there we go. Okay, so our A value is 1. The B term is always attached to your X term. Here is your X term. The number in front of the X is positive 7. I've got plus 7. So the B is just 7. Okay. Now your C is going to be your last number here, your constant. Okay. So your C is 12. Okay. And that's it. That's A, B, and C. All right. Let's try example 2. So do I have a quadratic? Is the degree 2? Awesome. Is the quadratic set equal to 0? Quadratic is set equal to 8. But I can set it equal to 0. How?
If you do the basic move of subtract 8 from both sides.
There we go. Okay, so let's set it equal to 0. Subtract 8 on both sides. So now my equation is x squared minus 6x minus 8 equals 0. Okay, let's go through our checklist again. Degree of 2, check. Equation set equal to 0, check. Now I can identify A, B, and C. Okay, so A is always attached to your x squared term. So Miss Gilroy, what's my A? Thanks.
2.
What's my B?
6.
6? Are you sure?
Well, that's the thing that's with the X, right?
Yeah, but can you double check that sign? What's the sign you see in front of the 6?
Oh, it says minus 6x.
Mm.
Oh, so the coefficient's really a negative 6.
Mm-hmm. How about the C?
Oh, it's negative 8.
There you go.
Almost at 8.
Almost. All right, and then that's our A, B, and C. All right, guys, let's do the last one. So again, we're just going to go through our checklist. Do I have a degree of 2? Is the equation set equal to 0? Awesome. What's my A term, Miss Gilroy?
Negative 2.
Awesome. How about my B term?
4.
And how about the C term?
96.
Woohoo! Awesome.
Okay, so we've got a few more practice problems here as well. So the checklist, quadratic, number 1, quadratic, number 2. Yep, they're both degree 2. Good to go. Are they both set equal to 0? Well, number 1 is. But number 2, Ms. Madrano, we need to do mark, don't we? So let's get that 30 over to the same side as the x squared and the minus x.
I'm going to add 30, right?
Oh, but then we'll have 60.
Oh, yeah, because if I add these two, okay, yeah, no,
Yeah.
I needed to set equal to 0.
Yeah, so let's add a negative 30 to both sides.
Plus negative, plus negative.
Okay. And then we'll have x squared minus x minus 30 is 0. And now we're good to go. Okay. One thing we might notice is that these are already in nice structure and organized thing. We've got our x squared term, we've got our x term, we've got our constant term. Constant is just a special word for just a plain number, no variable associated with it. So they're already nice and orderly. Sometimes you'll get some problems where they're kind of jumbled up, but you could always rewrite it so that they're in order from the biggest degree to the smallest degree. Okay, so I see in number 1 that the A value is 1 because there's no coefficient there. The B value is 6 and the C value is 9. Is that what you get, Ms. Madrano?
That's what I got too.
Okay, and the number 2, just to quickly check through it, A is 1, B is negative 1 because of that minus sign, and C is negative 30.
Awesome. All right, guys, so that's the first skill towards using the quadratic formula. We did that. Okay, so now let's put the quadratic formula into practice. So before we look anywhere, I want to draw your attention to this side of the screen. So where I just kind of scribbled in pink over here. So earlier in this video, we were able to find our zeros by factoring this same equation. Okay, so remember we factored it and we found out that x equals -3 and x equals -4 were our x-intercepts. If you didn't want to factor and you wanted to use the quadratic formula, you would be able to do that also, okay? So over here, now I'm gonna draw your attention here. I've already identified my A, B, and C, and I've highlighted it so that you can see where I'm getting those numbers from, okay? Then what I did next is I substituted the values for A, B, and C into the quadratic formula. So let's see, anywhere I saw an A, so I see an A right here and right here, I put in my value for A. So that means I'm going to put in an A right here. I mean, a number 1 right there and right there.
And Ms. Madrano, I love how you put parentheses around what you did for A. I think that's a really good thing to do. Helps you to keep everything organized.
Yeah, and it helps me to make sure that I've included the correct values where they needed to go. Okay. The next thing I did was I looked at my value of B, and that was 7. And I put it in wherever I saw a B. So I see a B over here, and I see a B over here. So I put 7 in parentheses here, and I put 7 in parentheses here. And then my C value, I put it in wherever I saw C, and there's only one C value. So I put C, the value for C, where it belongs in the equation. From there, I followed order of operations to help me simplify my equation, okay? So I know it looks a little overwhelming at first, but if we take it step by step, it becomes a lot less overwhelming the more we go. So let's follow the red arrows. So the first thing I did was let me use a different highlighter. So a negative times a positive is a negative. So I've got -7 over here, okay? The next thing I did was I looked at this part right here, this 7 squared. I know what 7 squared is. 7 squared is 49, and that's where this 49 came from, okay?
Oh, because 7 times 7 is 49. I thought it was 14 at first.
Oh, that's 7
I
times
remember.
2.
Okay.
Be careful, okay? The next thing I did was I took this whole thing right here. So I've got -4 times 1 times 12. When you multiply all those numbers together, you get -48. Okay, so that's where that 48 is coming from. And then I know what 2 times 1, and 2 times 1 is just 2. Okay, so that's where that 2 comes from. All right, so now that we know where these numbers in this second row right here are coming from, I can simplify it even more. Now I'm going to zoom in on the numbers underneath the radical. 49 minus 48. I know what that is. That's just 1, so that's where this 1 is coming from, okay? And then from there, I know what the square root of 1 is. The square root of 1 is just 1, okay? So now,
Toronto, I have a question.
yep.
What's with that that stuff that's in between the -7 and the 1? What
Oh,
does
this
it
thing right
mean?
here,
Yeah, what's it mean?
that like plus minus. So that's how we're gonna get our 2 solutions if the quadratic has 2 solutions. Now, Ms. Gilroy, we already know our solutions to this, right? We know what the x-intercepts are. We know that they're gonna be -3 and -4. But where do they come from? This is where they come from, this plus and minus. So what we're going to do is this helps me see how I'm going to get to those values. So I have -7, and I'm going to add it to the 1 first, all over 2. Then to get to my second solution, I'm going to get -7, subtract that 1, divided by 2. So really, I'm taking this symbol right here and separating it. That's how I'm getting 2 solutions. Okay. And then from there, I'm going to follow order of operations again. So what I mean by that is let's take care of the things in the numerator first. So -7 plus 1, that's -6. -6 divided by 2 is -3. That looks familiar. Okay. Now let's look at the next one. -7 minus 1, that's going to get me -8. divided by 2. Negative 8 divided by negative 2, or negative 8 divided by 2 is negative 4. Those are the same solutions that we got before. Now, the reason I use the same quadratic is because I wanted to show you guys that you can pick either method in order to find these zeros. Okay, you can either factor or you can use the quadratic formula. In some instances, it's going to be better to factor. In other instances, it's going to be better to use the quadratic formula.
Great. And then I think we've got one more practice, right?
Mm-hmm.
Okay, so check. Do we have a quadratic? Yes, we see the exponent is 2, and that's the biggest exponent. Is our quadratic expression set equal to 0? It is. So now we're going to identify our A, B, and C. So in this case, I see A is 2, B is negative 6, and C is negative 8. So we've identified each of our coefficients, each of the values, and now we can put those into the recipe, into our formula for the quadratic equation. And fortunately, it's written there for us. And like Ms. Medrano said, you can find some songs and other things, and eventually you might want to have this memorized. But for right now, we'll have it available for you. You can always look it up. Okay, so I need to put in the ingredients into the right places. So I'm going to start off with giving myself a big fraction bar, and I'm going to go ahead and start putting in the information. So I know I need negative b. So I'm going to do a negative sign and then parentheses, negative 6. Then there's that funny symbol of the plus or minus and a big square root symbol. I need to take whatever a or whatever b is squared, and then to help remind me that it's b that I'm squaring, I'm going to put negative 6 in parentheses and then square it. And I need minus 4 times my parentheses 2, and then times my parentheses negative 8, all over 2 times parentheses 2. And now I've used the ingredients that we had identified and put them into the recipe. We're going to stew it all up together and see what it ends up equaling. Order of operations, I'm going to tackle the stuff underneath the radical sign first. So I'm going to think about negative 6 squared. Negative 6 times negative 6, I'm going to get a positive 36. And then I'm going to subtract whatever 4 times 2 times negative 8 is. And I know multiplication comes before subtraction. So I'm going to go through that. 4 times 2 is 8 times a negative 8. 8 is 64. Okay, so I need to subtract a negative 64. And I can write that deliberately, or I could go ahead and say plus 64. Either way is fine. And right before that square root symbol was the plus or minus. So I'll put that back in. And the opposite of negative 6, well, the negative and the negative become a positive. So the numerator should be 6 plus or minus the square root of 36 plus 64. And this is all over our denominator ended up being 4. So then I have to find out what 36 plus 64 is. 36 plus 64 is 90. Let's see, 30 plus 60 is 96 plus 100. And I know what the square root of 100 is. So I'm going to write 6 plus or minus 10 all over 4. And to see the two separate things, I'm going to consider them separately. So I'm going to think about 6 plus 10 over 4. And I'm going to think about 6 minus 10 over 4. And then I'll go through the process, 6 plus 10. I know I'm going to do the numerator, the addition or subtraction that's in the numerator, because it's like it's in parentheses. And then I'll divide by the denominator. That's what order of operations tells us to do. So 16 over 4 gives us 4. And 6 minus 10 is negative 4. So negative 4 over 4 gives us negative 1. So I know the two x-intercepts for my quadratic equation, y equals 2x squared minus 6x minus 8, that parabola will cross the x-axis at 4 and at negative 1.
Okay. And so now we're going to go through one more example. So this is one for you to try. So here's a new quadratic formula to find the x-intercepts. So our equation is 2x squared minus 5x minus 3 equals 0. Okay, so now go through the questions in your head. Do I have a degree of 2? Yes. Is the equation set equal to 0? Yes. So now the first thing you're going to want to do is identify your A, B, and C. What I want you to do right now is hit pause on this video. I wrote the quadratic formula for you here on the screen, and I want you to try this one on your own. When you come back, we'll go over the solution together. Okay, welcome back. All right, so hopefully you have something written down on your paper. I'm going to show you the solution right now. We're going to talk through it really quick. Okay, so here is the solution. So I know that right now there's a lot of writing on the screen, but don't worry, we're gonna make sense of it together. So the first thing that I went ahead and I did is identified my A, B, and C. So for A, I got 2, B, I got -5, and C, I got -3. What I did next is I substituted those values for A, B, and C into our recipe, into our quadratic formula, and then I started simplifying from there. So from there, I took opposite of -5, so that's +5. And then I took -5 squared, so -5 times -5 is +25. And then I took -4 times 2 times -3, and I got +24. So from there, I got x equals 5 plus or minus the square root of 25 plus 24 all over 4. And then from there, I took care of everything that was underneath the radical. So 25 plus 24 is 49. Okay. So now I'm going to have to scoot down on my screen just a little bit. There we go. And then from there, I took the square root of 49. So the square root of 49 is 7. And so that's how I got that line down there. From here, I went ahead and I separated the plus and the minus symbol so that I could see my two solutions. So that's what you'll see over here. So there's one of my solutions, and here's the other one. So on the top one, you'll see x equals 5 plus 7 divided by 4. I took care of the thing in the numerator, and I got 12 divided by 4, which meant one of my solutions was 3. Right below that, I got x equals 5 minus 7 divided by 4. So when I took care of that, I got -2 divided by 4, and I got -1/2 when I simplified that fraction. Okay, so these are my two solutions. Got x equals 3 and x equals -1/2. Okay, that's all we have for you guys, but go ahead.
There's one thing I do want to mention. All of these examples that we walked through today ended up giving us a nice square root, something that was friendly, that we could actually find a square root because it was a perfect square number.
Mhm.
That won't always be the case. In fact, if you want, you can look back at the last two problems from the class notes from our previous lesson. Those two ended up being a little funky, but you know what? It's still something. This quadratic formula will work. This is a weapon that can be used on any quadratic.
Mm-hmm. And so what we want you guys to do is to go ahead and try the practice problems in Google Classroom and submit them. And don't forget to turn in your project. Don't forget to stay on top of your Alex. Don't forget to take care of yourselves and your families. We miss you. We love you. We hope that you guys are doing well. And we hope that you guys will stop by next year and say hi and tell us how your summer went, because we'd love to see you and hear from you.
Yes, take good care.